Imagine, for a moment, that everything you thought you knew about our planet was subtly, fundamentally wrong. That there was a secret, an enormous piece of Earth, hiding in plain sight. Not a mythical Atlantis, but a real geological behemoth, a continent the size of Madagascar, patiently waiting to be rediscovered. The most astounding part? It's been right under our noses the whole time. How could we possibly miss something so vast? And what does its hidden existence tell us about the very definition of a continent? For centuries, the map of our world seemed settled. 7 continents, vast, distinct landmasses rising proudly from the oceans. But what if that familiar map was incomplete? What if the geological forces that shaped our planet had played a trick, submerging a substantial landmass just enough to obscure its true nature? This isn't science fiction. This is the story of Zealandia, the Earth's 8th, mostly submerged continent. The very idea of a hidden continent sounds outlandish. We've explored the deepest trenches, mapped the highest peaks. How could something so large escape our notice? The answer lies in how we traditionally define a continent. A large, continuous landmass rising above sea level, distinct from oceanic crust. But Zealandia challenges this definition, because 94% of it lies beneath the waves. Geologists have a more technical definition. For them, a continent isn't just about what's above water. It's about the crust itself. A thicker, less dense, and chemically distinct type of rock compared to the thinner, heavier oceanic crust. This continental crust is like the fat on a bone, rising higher because it's lighter. And under the waves of the Pacific, scientists began to detect an unusually thick continental-type crust. The first hints of Zealandia emerged surprisingly early. As far back as the 1920s, geologists exploring New Zealand and New Caledonia noticed something odd. The rocks weren't typical of oceanic islands. They looked distinctly continental, hinting at a much larger, submerged geological structure. But without the technology to map the deep ocean floor, these observations remained isolated curiosities. It wasn't until the advent of sophisticated deep-sea mapping technologies, particularly during the Cold War and later for oil and gas exploration, that the pieces began to fit together. Sonar surveys started painting a picture of a vast, elevated submarine plateau spanning millions of square kilometers, distinct from the surrounding oceanic abyssal plains. This wasn't just a collection of islands, it was a coherent, massive feature. But mapping the topography was just the beginning. The crucial question remained, was this submerged plateau made of continental crust, or merely unusually thick oceanic crust? To answer this, scientists needed to see beneath the seafloor, using seismic surveys. These surveys send sound waves through the Earth's crust, and by measuring how fast they return, geologists can determine the density and composition of the rock layers below. What the seismic data revealed was groundbreaking. The crust beneath Zealandia was significantly thicker and less dense than oceanic crust, echoing the characteristics of continental crust found in places like Australia or Antarctica. It stretched for 4.9 million square kilometers, an area larger than India. This wasn't just a piece of the puzzle, it was the whole board. So, how did this continent end up underwater? Zealandia's story begins over 80 million years ago, as part of the ancient supercontinent Gondwana. Imagine a colossal landmass stretching from modern-day India to South America. As Gondwana began its slow, dramatic rupture, Zealandia, then part of a larger land bridge, started to stretch and thin. This stretching process is key. Unlike a clean break, Zealandia's crust was pulled apart so slowly and extensively that it thinned significantly, like pulling taffy. It didn't quite snap, but it became much thinner than typical continental crust. This thinning caused it to sink lower into the Earth's mantle, allowing the ocean to gradually inundate most of its surface. It was a continent, but a very, very stretched and submerged one. Further evidence came from deep-sea drilling. Scientists drilled cores into the Zealandia seafloor, extracting sediment and rock samples. These samples revealed not only continental-type rocks, but also fossilized pollen and spores from land plants, indicating that this area was once above sea level and supported complex ecosystems. The fossils were indisputable proof of a terrestrial past. Despite its submerged state, Zealandia isn't entirely static. It sits on the volatile Pacific Ring of Fire, a hotbed of tectonic activity. The friction and pressure from these immense forces continue to shape the continent, slowly uplifting certain areas, like the mountains of New Zealand, and creating dramatic geological features. It's a continent that refuses to simply disappear. So, what does this rediscovery mean for our understanding of Earth? It forces us to reconsider what a continent truly is. Is it purely about land above sea level? Or is it about the fundamental geological properties of the crust? If we strictly adhere to the geological definition, Zealandia unequivocally meets the criteria: distinct crustal type, large area, and clear boundaries. The official recognition of Zealandia as Earth's eighth continent is not merely an academic debate. It fundamentally alters our global maps and geological understanding. It means that for millennia, humans have been navigating, living near, and even on a continent whose true nature remained largely unknown. It's a humbling reminder of how much more there is to learn about our own planet. Imagine what life might have been like on Zealandia before its descent. A lost world of ancient forests, unique animal species evolving in isolation. The few fragments that remain above water, like New Zealand, offer a tantalizing glimpse into this past, with their unique flora and fauna that diverged from their Australian counterparts millions of years ago. But here's the profound twist. Zealandia's submergence wasn't a sudden cataclysmic event. It was a slow, relentless process, stretching over tens of millions of years. This gradual sinking means that its ecosystems, if any survived, would have been slowly extinguished or forced onto the diminishing land masses. It's a testament to the Earth's patient, immense power. The implications extend beyond just adding a name to a map. Understanding Zealandia's geological history helps us refine models of plate tectonics and continental rifting. It provides a unique natural laboratory to study how continents stretch, thin, and sometimes almost entirely disappear beneath the ocean, only to be rediscovered through scientific detective work. The journey to recognizing Zealandia involved decades of international scientific collaboration. It wasn't one eureka moment, but a slow accumulation of data, cross-referencing, and persistent questioning of existing paradigms. It highlights the often incremental, yet ultimately transformative nature of scientific discovery. The largely unexplored depths of Zealandia likely hold countless secrets, from unique deep-sea ecosystems adapted to specific conditions to perhaps even more surprising geological formations. The journey of discovery is far from over. This new continent reminds us that even in our highly mapped world, vast, complex mysteries still lie hidden, waiting for the next generation of explorers. The story of Zealandia is a powerful metaphor. It teaches us that our perception of reality, even something as fundamental as the number of continents, can be limited by our tools, our definitions, and our assumptions. It challenges us to look deeper, to question what seems obvious, and to embrace the humbling fact that the Earth still holds profound secrets, even in plain sight. So, the next time you look at a world map, remember Zealandia. Remember that underneath the vast blue expanse of the Pacific lies a continent that was once a vibrant land, stretching and sinking over millions of years. A silent witness to Earth's dynamic past. It wasn't lost in the mythical sense, but hidden by a grand geological process, patiently waiting for science to reveal its true identity. Its existence fundamentally shifts our understanding of planetary geography. It confirms that the lines we draw on maps, the classifications we create, are often just snapshots of a much more complex, ever-evolving reality. And it makes us wonder, what other hidden features, what other forgotten pieces of our planet might still be waiting for us to rediscover?